Hello, viewers. Welcome back to day 4 of my day 30 days challenge of trying to share my knowledge and tips as I was a student and as a teacher, and how to make children prepare for exams. Thank you for joining me here. Day 4 of my okay. So if you have any questions for me, leave it in the comments box, chat box, and I will look at it for in a gap of 10 minutes or so, because when I am explaining something, I just don't want to cut the flow. But I'm here to answer your questions as well. Every 10 minutes we will be doing, right? So today we are talking about how to calculate fastly and review fastly also. Before I start the entire thing, let me give you a context again. First of all of you parents or all of you people who are watching have to understand one small thing, that math is not just about numbers. Of course, math is about numbers. I'm not saying no. That's how all of us got introduced to mathematics. As soon as we say math, the first thing that LKG child or UKG child learns is 1, 2, 3, 4, 5, 6 and ONU 1 only. So, because it was like that, that's the reason all of us think that math is about numbers. But actually, math is not about numbers. Math is about thinking. And that is why, though I had the scope of learning Vedic maths, abacus, or some other mental mathematics techniques and everything, as a math lover, I could have learned any of those things. But then what I discovered early in my student life as a teacher is that if I want, I can invent techniques just like great mathematicians, who have done Vedic mathematicians. We're all coming from the same genes. So I believed that if they can come up with some techniques, I can also come up with the same thing. And if I am in a situation where I would require to use their techniques, I would love to learn from them also, learn from our ancestors and elders. But believing in my own potential, believing in every human being's potential, every child's potential. Now, what I am saying is, if your child wants, if your child falls in love with mathematics, they can come up with calculation techniques. That's what I believe, and that's what I encourage my students to do. And thereby, here I'm than saying calculating techniques that I'm going to show that everybody does. I'm going to show that your children have that potential to come up with that technique on their own, because I was able to do it as a small child, as a student. I was able to do, and I was able to encourage many of my students to calculate on their own, come up with their own techniques to calculate. And what sticks is with a person is what they have done on their own. It will not be many times, it's not something what we teach children, but something what they have discovered themselves, what they have identified, what they have invented themselves. Those are the things that will stick with them throughout life. And that's my belief. And that's why I say your children are already a math champion, already champions. There is a mathematician in a child already. So, giving this context, I would like to start today's live with I'm going to share five best practices for learning calculations. Okay, and one more thing also I would like to share, that this is not the end of the calculation techniques. In my 30 days live, I will also be talking about many more techniques and practices and everything. But today I've chosen five, and let me cover those five. And before that, let me give you a context. And one more thing I want to share with you all, that please start making your children practice this affirmation. I am a mathematician. There is a mathematician in me. If I try, I can do math. If I try, I can do math. If this opens up a whole lot of possibility in your children. So I'm just repeating the same thing. There is a mathematician in me. If I try, I can do math. Make them repeat this early in the morning as soon as they get up or just before they go to bed. Make them repeat it. And if this idea gets settled down in their subconscious mind, then nothing can stop them. Just today, I got a review from one of the parents of my Math Champion program that the child is doing fantastically. And all that credit goes to this affirmation that the parent made the child. You might say, what is there in telling this? I'm telling you, I will not be able to delve into that deeply. If you believe in me, if you think that is going to help, I'm telling you, make your children tell these affirmations. There is a mathematician in me. If I try, I can do math. Okay. If you make the children tell this, then whatever techniques, whatever we are teaching them, everything will go directly inside them. That's a very important thing. Okay, let's start with our five best practices. Quicken our calculations. So I'm going to share my screen there for you. Okay, so this again is a document. I will be sharing the link of that document in my first comment of this recorded video. Okay, 5 practices to quicken math calculations in 7 days without counting on fingers. That's the challenge I give to myself. Think math, do math, right? This is a document that I prepared. Now, when we make children start their learning journey, we ask them to learn through fingers. But the problem is children have at that age have a very high visual memory. So there is something called coolmathforkids.com. There you have this 10 frames. This kind of 10 frames is there. 10 frames is nothing but you have a box, a rectangular box with 10 boxes in it. Sorry, though it's okay. 10 boxes in it. It has just like this, what I've shown here. And children start learning 5 plus 1, 2 plus 3, everything visually they start seeing. When they start seeing visually, then what happens? They are able to add single digit numbers quickly. Like, for example, I have this thing, right? I have it here. I have it here, here. And I say this is 3. This is 3. Children learn that. Then this is 2. Then they see this entire row is filled. This row is 5. Then one more way I could do the same thing. One more way I could do the same thing. All the different combinations that can come, which will add up to 5. That if they see often with their eyes, right? Like for example, 4 like this, and then a 1, a different color. What happens? All these calculations, 4 plus 1, 2 plus 3, all these things, they see, as soon as they see immediately, they're, oh yeah, this is 5. Okay, this is 7. This is 6. I'm telling you, first, what all possible combinations are there for a 2 to come? 1 plus 1, 2 plus 0. For what all combinations for a 3 to come? 2 plus 1, 1 plus 2, right? And 3 plus 0. What are possible combinations for a 4 to come? 1 plus 3, 2 plus 2, 3 plus 1, 4 plus 0. All these combinations visually they see. All of you understand that it is just any addition, any subtraction. Finally, we actually break down to adding a single digit with a single digit. That's what we do, right? We don't do double digit more. We do single digit more. And like this, if you do till the 20, what all combinations can come for a 20? Addition and subtraction, both visually using this 10 frames. Using this 10 frames, if you do, then it all becomes so easy. So easy. And once they finish learning that 20 addition, subtraction, both, what all possible combinations of 20 can you get using subtraction? 20 minus 0. What all possible combinations can you get for a 18? Get a 18. What all combination is subtraction? Right? 20 minus 2. 19 minus 1. All of this in that 10 frame. If they do that, in the beginning, it will take for you maybe 1 or 2 days to make them visually see it. But once they do that, they become pretty quick in doing it. The only trick that I'm telling you here is visually show them the 10 frame, and with the 10 frame, let them move it and do it. Then there's something called a 10 frame mania game. That link also I will share in my comment below. That game will actually make it gamified way quickly they will do. Why I'm saying only the best practices. I'm not teaching them how to, what is a technique to add a 19 minus 19. I'm not teaching them those techniques. Why? Because when you give all these models, these are just models, it will enable the child to think in different ways, using their mind, using their visual perception of everything. They will come up with new, faster ways. Our mind is equipped to optimize our capacity. For that, you just need to give challenge. Challenge, that is the reason I'm saying the next thing is 10 frame mania game. It will challenge your child's capability to use the things that they've seen visually. Once these two things happen, single digit and double digit addition and subtraction gets sorted. That means those calculations children will be able to do quickly. Now, there are many methods, right? Counting on fingers, those things. But for all of those things, it's all two step. But this visual method, it's just one step. Means brain starts thinking in a certain way, and you are able to see it, and you are able to get it. That's it. There is no two step. There is no counting, figuring out how many fingers is there here. Nothing of those thought. It's directly mind. Like in my previous life, I told you that mind thinks in images. So you show in images, then children pick up quickly. And if you're saying my child is already in 5th standard, still give the same method, do the same method. Maybe 5th standard children may take lesser time than a 1st standard or 2nd standard children. Right? Okay, that's the first practice. Then use properties of the operations. Many of our children don't really give importance to these properties. Properties means what? Like addition or subtraction. 7 plus 8 is same as 8 plus 7. This is called commutative property. You flip the numbers, still you get the same answer. But that is the same thing will not work for subtraction. Means these two things are not the same. From the 7, you cannot remove a 8. Right? At least you cannot get a positive number as answer. From a 8, you remove a 7, you get a 1. Right? So this is not equal. So having these kind of differences will also help children figure out bigger calculations. When they have bigger calculations, like many calculations are there, then they will know that, oh, I have to use this, I have to do this. So this is called commutative property. What is associative property? Associative property means you group the numbers. Right? If I'm having like this, I could group like this, or what will be easier? Now again, 10 frame method, if you've already done, then children will know, oh, in addition, I can group anyway. I will get the correct answer. This concept they should know that, oh, I will group these two. I will get a 10. And then I will add 8. 10 plus 8 is always 18. So those kind of additions children will be able to do easily. And now here we are exploiting one of the properties that is there in mathematics already. For this, again, the 10 frame technique 10 frame methodology, 10 frame model is the basis for this also. If your children are able to do that one quickly, correctly, the next step is teaching them that commutative means in addition, however you flip the numbers, it's the same. Answer will come same. In addition, however you group the numbers, that answer will come same. Addition, right? But in subtraction, if you group in different ways, it will not come. In subtraction, if you flip the numbers, if you exchange, swap the numbers, it will not come, same answer will not come. So such concepts, if they know, then it becomes very easy for them. Now, let's go to the next property called the distributive property. Distributive property, how it will help them? Now, say for example, we're supposed to do 26 times 7. 26 times 7 they have to do. Now, this they will do normal methodology. Do very good, let them do. Now, one more challenge children face is they're doing calculations. Once they do calculations in the test paper or exam paper, now you always tell, many of your parents will tell them, check your answers, whether it is correct or not. They can check and they will check. Sometimes they will forget also. But there is two challenges in this. First thing is they have to check, they have to do the calculation again. Okay. They have to do the calculation again. And while checking also, you have to do the same calculation again means, then again it's like writing the exam second time. Right? Doing the problem second time. Where is that much of time in exam? It is not there. And the second problem is, when they're checking also, they do the same method only. When they're doing the same method, there's all the possibility of doing the same mistake that they would have done in the previous time when they did. Like if they have multiplied, say 6 sevens is 46. If they have told like that, told to themselves, and write there also like that only. And next time also 6 sevens is 46 only, they will say. What is the point in checking? So the solution for this is children should know many methods of doing the same question, same calculation. They should know many methods. One method they should do as per what is required in the school examination or something like that. And the second method should be a quick method which will give them a approximately correct answer. Here is where estimation skill of mathematics comes. I tell all my students in the Math Champion program or other students also, I tell this that in life, we don't use exact mathematics. Nobody uses exact mathematics. Like not in daily life, I'm saying. We use approximate mathematics. That's called estimated mathematics. Let it be stock market. Let it be a mother cooking in the house. What kind of mathematics we use? We estimate. We say this is closest to this. Okay, this much is enough. Or this is the so much nearly so much is what I would require. Right? We do estimated mathematics more, and thereby children should be trained in estimated mathematics. And for that, so let me go with this where I'm going to mix both the things, right? Commutative property as well as estimation here. Not commutative, distributive property. Now, how we can do this? Okay, children will do 26 times 7. The normal method they will do. Okay, the normal method they have done and they have got an answer. I'm not going to do the normal method. I'm going to show you the short method. So, what is a short method to do? Like this, children can split it into 20 and a 6. The question asks 26 times 7. So I will say 20 times 7 first. 20 times 7 is, I know it will be 140 because in the multiplication, we just take the 0 inside. 0, the answer, right? And 6 times 7. 6 times 7 is 42. And then I will add it. So here came one more method of doing the same problem, same calculation, so that they can check whether they did correctly or not. Now you might say, 6 times 7 is same thing as you told they would have done wrong. No, they would have done wrong. Okay, no problem. Instead, here, instead of a 30 and a 6, they can, if the 6 table is what something is very difficult for them, or 6 and 7 is, they can make it smaller. This 26 itself can be written as 30 minus 4. Again, here we are using the 10 frame model. If children are trained in the 10 frame, they will know that 26 means I can write 20 plus 6 also, I can write 30 minus 4 also. Again, the basis, the foundation is the same, 10 frames. So 26 I could write as 30 minus 4. Now what I do 30 times 7 and 4 times 7 and subtract it. So 30 times 7 is 7 is a 21, 220, 210. And 4 times 7 is a 28. So I know the 4 table properly, I know. I maybe you know that your child is not well versed in 6 table or 7 table, but a 4 table is they know better, maybe, right? So 4 times 7, and then I know it's a subtraction here, so I subtract it. I get the answer, which is the same, which will be the same, right? So 20 minus 8 will be correct. 182, same thing I got. Previously, I had got 140 plus 42, which is a 182. Here I'm getting a 210 minus 20 is a 1. So this is nothing but distributive property. Problem is, all these properties that is there in mathematics, which will help us, that is given sometimes least importance by the learners. I wouldn't say teachers. Learners give little bit less importance to learning these properties, but these properties is what is going to help them do quickly. We don't have to learn any more techniques, Vedic mathematics techniques and all. That's what I believe in. Now, the same 26 times 7, that's what we had taken. Now, how can we check the answer quickly? So for that, we do an estimation. This is something like it is near to 25 or a 30, right? 25 or a 30, it's near. So 30 times 7. 30 times 7 is a 210. And our answer was 184, 182. Yeah, 182 it was, right? So when they do this, they just have to quickly see. Okay, 26. Okay. If they don't have any much time, okay, 26 means 30. 30 times 7 is 210. 210. My answer, 182 is very near to 210. And my answer most probably is correct. This technique I'm saying is for reviewing. Quickly they can review their answers by using estimation. Let it be addition, subtraction, anything. Let's say 1897 plus 4222. They're having such kind of addition. Now, if children are able to estimate, this is something like 1897. Estimation is something like 2000. 4000 is 4200 something is like same as nearby 1000 is 4000. So my answer should be nearby to 6000. Let's do that actual addition. Actual addition is, you get it 6190. And what I did here, 1800 means it is nearby to 2000. 4200 means it's nearby to 4000. Oh, 2000 plus 4000 is 6000. And my answer is coming near to 6000. They don't even have to write the calculation again, but use the estimation and review the answers quickly. And by this, if they have done something like, something like, 200 and something like that and all, they will know that, okay, it's little farther. It is little farther. Should I check the answer correctly again once more? Okay, let me check. This is the actual checking. So I'm saying this is a quick estimation, is a quick way to do it. I'm not saying it is the absolute way. All of us know it's not the absolute way to do that, right? But if they have to check, they can check within few minutes using that. So use the properties. Next thing is, if you come to factors, HCF or LCM, like that and all, when they have to find out the factors, they have a difficulty in finding what all could be the factors for this. Now, let's take a number called a 24, or let's take a 12. Okay, 12. So I call this as rainbow of factors. Many of you would know also. many of you will know also. Like we start with 1. 1 in the one table, always you get a 12, right? All the numbers you get. So 1 times 12. I write the 12 here. These two multiplied will give me a 12. The next, the 2 table. Add 2. 2 times 6 will give me a 12. Then 3. 3 times 4 will give me a okay. 3 times 4 will be a 12. And between 3 and 4, there is no numbers. That means all these are the factors of 12. Now, many a times when children have to do fraction division, simplification of fraction and everything, they struggle because they have to do many steps. Now, for example, if we have a 12 over 36, if they have to simplify this fraction, what do? They again start by 2 table, 3 table, 4 table and everything. But if they can find out factors of 12 like this and factors of 36, just like that, okay? Let me take that. Let me take the factors of 36. Again, I start with 1 times 36, 2 times 18, right? 2 times 18, 3 times 12. What happened? I don't have to do any further. I know here also 12 is there. Here also is 12 is there. So I can just divide this by 12 directly. 12 ones are 12 threes are, and I get the simplified fraction of 1/3. I will get it quickly and effectively. I will be able to get. So this rainbow of factors is one of the other practices that I'm talking about. Next thing is practice 4 is about divisibility rules. If children know the divisibility rules of every number, like every even number is divisible by 2, every number, the sum of the digits, if you add the digits, like for example, if I want to know whether 1247, can I divide it in 3 table? Means 1 plus 2 plus 4 plus 7. I have to check whether this will give me 1 plus 2, 2, 3, 3 plus 4 is 7, 7 plus 7 is a 14, correct? This 14 does not come in the 3 table. So therefore, this 1247 also is not divisible by 3. We cannot divide it in 3. Okay, quickly say that, isn't it? So like that, all the divisibility rules, if they know, then simplification of fractions, taking the fraction addition using the LCM method, that is like two different unlike fractions addition, all of those things will become easier and faster if they know the divisibility rules and they use the divisibility rules in their calculations. Now you might be thinking, ma'am, we came to the live thinking that you will teach us many techniques and all, and you're telling us some things that is like we have to learn and it will take time. But if you learn these things, not only for this exam, it will your children's problems for all throughout the long exams, throughout their learning time, is all of that is sorted. All of that is sorted. And you said, ma'am, there's so many techniques, and you've just told the 5 techniques, and that means that more to learning calculations, is it? Yes, there are more to learning calculations. Then you might say, ma'am, it's very easy, instead of all this, I can just do Vedic mathematics or something like that, which will help me in doing those addition and everything. Well, let me tell you, there also in Vedic mathematics or anything also, they give you for this condition, like if the numbers are having 11 or multiplying by 11, or okay, there also Vedic mathematics or anything is also somebody's methodology, somebody's method. They found out that certain kind of numbers follow certain kind of trend, and that trend is what they have given you. And in your calculations, first of all, you have to remember that trend, and for that trend, what is the technique, and you have to see whether the trend is what is there in your question, in your calculation. You would remember all those things. Instead, I'm saying, instead of saying, okay, MAT, 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 like learning to pronounce every word. Instead of that, why not learn M means m, A means T means t, t. I'll go to join all those things and read. I'm saying learn the sounds itself so that you can learn. Like that, learn the principles of mathematics itself so that you can use it anyhow you want it. This is like learning phonics sound. If you know learn phonics sound, you can read any word in any book. It's like that. If you learn these principles itself properly, all these are principles that is there in mathematics. But from my experience, I know that this is a subtopic in a chapter, divisibility rules. We neglect it. It's okay. 1 or 2 marks only come from this. But addition, word problems, those only come. I learned that. So there's a gap, which from mathematics itself, what could help you in your calculation that you are disregarding and not learning, like the properties, like the divisibility rules. Those things are going to help you in your calculation. So learn those things and make your life easy. Mathematics has made your life easy. Mathematics is there to make your life easy. But if you don't learn what are the things that will make it easy, then that is where you get into trouble. The next thing is, the last practice I'm saying is memorize some common numbers. Memorize some common numbers means like square numbers. As soon as I see a 9, I should know that it is 3 square. As soon as I see a 64, I should know it is a 8 square. Why? Because when you're doing some calculations, when you go to high school, like 7th or 8th grade, when you see the 81, you'll be wondering, if you don't know this, that 9 square is 81, you're wondering what I can change this as. There's a x square here, there's a 81 here. How can I change it? What can I do? You will not know. So memorizing certain numbers means square numbers. It's like when a child is very young, you learn what all is even numbers, what all is odd numbers, right? Like that, what are square numbers? 1, 4, 9, 16, 25, all that. When you have cube numbers, 1, 8, 27, 64, all those numbers. Then come numbers like 0.25. That means it is nothing but 1/4, or it is nothing but 25%. 0.5 is nothing but simply it is 50%, or it is 1/2. 0.75 means it's 3/4 or a 75%. Like that, you can have some numbers, some things which will repeatedly come in your calculations that you can remember. And for Pythagoras theorem, some Pythagorean triplets are there. 3, 4, 5 means when in a right angle triangle, if 3 and 4 is there, the side must be 5. If a Pythagoras right angle triangle is having 13 and 12, the other thing must be 5. So 5, 12, 13 is a triplet, like jodi, right? 6, 8, 10 is a jodi. It's all together, right? It's a triplet. So such things which are common, which is always repeated, which comes often, like 27 is 3 cubed, 49 is 7 square. Such things, if you know, then I call one more thing called as a manipulation skill in mathematics. That will become easier for you. And it will become easier for you to calculate in calculations as well. So more about this in my subsequent lives. Join me in those lives as well to unlock the potential that you have. And let me see if we are having any questions. Okay, there are no questions here. There are no questions here. If there are any questions, leave a question on a comment also. I will take that up in my subsequent lives and I'll share whatever I can about that particular question. I believe that I don't know everything, but I also believe that whatever I know, without sharing that, if I go off from this world, Lord will not forgive me. So your questions will lead me to fulfill my purpose of sharing what all I have inside me, whatever the Lord has given me knowledge through great teachers and mentors. Right? So ask me questions that you have, and I will be happy to take those questions as my subsequent live topics and share the knowledge that I have in me. That is the whole point of this entire live series. Thank you for joining me live. And I'm very happy that so many of you are responding with so much love and so much comments and everything. I'm so happy for all of your best wishes and prayers. And my prayers are with your children. I want them all to succeed and become, realize their true potential in life. And that's my vision for the world. Thank you so much for joining live. See you tomorrow at 6:30 p.m. again. On weekends, let's do at 6:30. On weekdays at 7:30. Tomorrow again at 6:30 p.m. Let's meet you all. Thank you. Until then, bye-bye.